vitamins. As mentioned in the introduction, we have two groups of vitamins, the fat-soluble vitamins and the water-soluble vitamins. Both groups differ in some intrinsic characters that will be discussed later. Vitamin D. The second member of the fat-soluble vitamins is the vitamin D. The sources of vitamin D are also animal and plant sources. We have another source is ultraviolet radiation. Before we discuss the vitamin D, it's worth mentioning some high-risk individuals, which are the dark-skinned individuals and older adults, also breastfed infants from vitamin D deficient mothers. Some points we should remember or keep in mind is that sunscreens with a sun protection factor of 8 and above prevent vitamin D synthesis. So sunscreens should be applied only after enough time has been elapsed to provide sufficient vitamin D synthesis. And exposure to the sun does not cause vitamin D toxicity. And so for most people, exposing the hands, face and arms on a clear summer day for about 15 minutes a few times a week should provide sufficient vitamin D. Dark-skinned people require longer times for sunlight exposure as they have excess melanin, which is a skin pigment that is a natural sunscreen. Dietary recommendations assume that no vitamin D is available from exposure to sunlight. So people who don't have some outdoor exposures or who live in northern or predominantly cloudy climates need to pay attention to their dietary sources for vitamin D. For the sources and requirements of vitamin D or cholecalciferol, the requirements of vitamin D about 200 international units up to the age of 50 years. But beyond this age, these requirements are doubled or tripled to about 600 international units. The sources of vitamin D, as we mentioned earlier, the first of which in mammalian cells is the ultraviolet radiation, which forms cholecalciferol or vitamin D. The process of vitamin D synthesis or cholecalciferol or vitamin D3 starts on the skin, starting with cholesterol, which is converted to 7-dehydrocholesterol, and the B ring of this 7-dehydrocholesterol is opened by the effect of ultraviolet rays, ending with vitamin D3 formation. This is also what happens with ergosterol, with ultraviolet rays forming vitamin D2 in plants. So it takes three stages for the vitamin B2 synthesized, starting with cholesterol under the skin and 7-dehydrocholesterol, where this cholecalciferol passes after forming the vitamin D3 to the liver, where it is hydroxylated at the 25 carbon by a 25 hydroxylase in the liver. This is followed by another step of hydroxylation by 1-alpha hydroxylase in the kidney. This process is controlled by the parathyroid hormone, which is responsible for activation of the 1-alpha hydroxylase in the kidney. This enzyme is also activated by other hormones, which are estrogen and prolactin and growth hormone. And this is important in females during gestation and during the period of lactation. The 1,25-dihydroxycholecalciferol, or the active form of vitamin D, performs many functions regarding the calcium or controlling calcium level in blood. It's responsible for stimulating sense of calcium binding proteins and alkaline phosphatase, and responsible for increasing intestinal absorption of calcium, which consequently leads to elevation of plasma calcium ion concentration. And this is the role of vitamin D in control of calcium levels in blood. So, summarizing these important steps, the one that occurs in the liver, where cholecalciferol undergoes 25 hydroxylation to yield 25 hydroxycholecalciferol, and in the kidney it undergoes further 1-alpha hydroxylation to produce the 1,25-dihydroxycholecalciferol or vitamin D, and its production in the kidney is catalyzed by the 1-alpha hydroxylase that is under control of the parathyroid hormone, and also the estrogen, prolactin, and growth hormones. The 1,25-dihydroxycholecalciferol or vitamin D induces the production of calcium binding proteins. These proteins sequester calcium and buffer the high calcium levels in blood, which occurs during the initial absorption, and allow calcium to be absorbed against a high calcium gradient. And as we mentioned, that estrogen, prolactin, and growth hormone have a role in stimulating the 1-alpha hydroxylase, the step that occurs in the kidney, thus increasing calcium absorption during pregnancy, lactation, and growth. And this secures the sufficient calcium during these periods. Many of the biological functions of vitamin D are related to calcium and its regulation or normalization or maintenance of sufficient calcium levels in blood. And this is done by three mechanisms. Vitamin D increases calcium absorption from the gut and This is a rule exerted on the intestine. It increases intestinal calcium absorption. In the kidney, it increases calcium reabsorption, and it has a role in bones. It releases calcium in the bloodstream in response to low calcium levels. So it is responsible for stimulating osteoclastic cells in bone, or bone mobilization, or bone resorption. This process of bone resorption is in equilibrium with the process of bone mineralization, and this role is also played by vitamin D. Vitamin D is also responsible for absorption of phosphate from the intestine and increasing phosphate reabsorption from the kidney. So from the previous discussion, we found that, or we can notice that vitamin D deficiency may be linked to manifestations of calcium deficiency. And these manifestations are manifested in children and in adults. In children, it's manifested as rickets, or softness and deformities in bone skeleton, and in adults it's manifested as osteomalacia, represented by weak bones, bone veins, and increased bone fragility and fractures. In children, the manifestations appear in their skeletons, where the skull has a box shape with delayed closure of the anterior fontanelle of the skull, bowed legs, and we can feel the rosary beads in their thorax, where the ribs have some thickenings as a costochondral junctions, which can be felt as rosary beads. So these deficiency manifestations, the rickets, in which the gross plates are affected, and occurs in children. There is bone thinning or hypoplasia, with decreased bone mineralization or hypocalcification of bones and enamel of teeth. And the osteomalacia, where there is incomplete mineralization of osteoids and occurs in adults, which are poorly exposed to sun, or females which have repeated pregnancies and lactation. The last point is vitamin D toxicity, which is most likely to occur when vitamin D is consumed in excessive amounts through supplementation. The excess administration of vitamin D raises blood calcium levels, resulting in calcium precipitation in soft tissues, or calcinosis, and stone formation in the kidneys, where calcium is concentrated or becomes concentrated in an effort or trying to be excreted. So there is frequent renal stones. And this ends the lecture for vitamin D. You can find more information about these topics in this site.